Hi, my name is Lan Anh, and this is my presentation for the open source contribution project. So for this project, I chose to contribute to the Faker, Python Faker library. It's a very popular Python library for creating realistic synthetic data like names, addresses, currency, social security numbers for developers to test their applications or, to see the database. It's really a massive project with over 18,000 stars on GitHub and is used by hundreds of thousands of developers. And this is a little bit of work through of this code base. So first up here, we have the faker provider, which is all the data provider has been created by the community. We have right here, like, for example, company, credit card, currency, even date time emojis. And then there's a couple documentations like the contributing guide or the code style guide. And in the test folder provider, it's all the test cases for each of the corresponding provider. So that's a little bit of overview of the code base. In terms, and the issue I chose to work on is called the Astron password generator or provider, and this one is requested by a random user, which asks to generate a password of a certain length. And this is my implementation. So these are what I added, my contribution. So this is a password provider built on the base provider class of the Figure REPL. And then there's only a function called strong password where not just the length, I also taken the other constraint like the minimum uppercase character, lowercase digits and symbols, and also a Boolean flag that allow ambiguous or not. And then what I did essentially here is just checking for other like any value error, logical constraints such as minimum must be non-negative or the length must be higher than the minimum, the sum of all the minimums, and then I create the list of all the characters of different classes, filter out ambiguous if we have to, and then uh randomize the characters from those lists to extend it to the password chars list, and then just from each corresponding class, and then just what if we haven't reached the minimum length yet, just add more characters until we reach the minimum length. And after we add everything, shuffle it one more time to make sure we had a randomized password, and then return the password string. And then for the test password.py file, I have these are a few helper functions to build the uh password provider, and then so this one tests for basic constraint to make sure the password we created meet those are the requirements that we set out. Test no ambiguous by default. Test the minimum cannot exceed length. Test minimum must be non-negative. Test the reproducibility. This one is just make sure that if we put in the same seed into the faker, it should create the same password. It's just the property of the provider, the base provider. And then test the sum of minimums, the exact sum of minimums only. Test zero simple requirements is allowed. And then when there's digits only and it's equal length, and then there's no white space. So that's a couple of test cases that I wrote. Then I'm gonna run it, and as you can see, it passes all the test cases. So that's what I did. And then in terms of reflection, so I think what went right was that I feel like the Faker REPL library, the Faker code base is really straightforward. The architectures, everything is very clean, easy to understand, very approachable, and definitely very easy for someone, a beginner like me, to understand and having really no trouble with, getting in and implement my first provider. And then I also ran into a couple problems when I implement my password provider. The first one was, uh, the first one was when I realized that I was accidentally creating like a predictive password pattern because like I didn't add like a shuffle logic at the end, but then I caught that and I added to make sure that my password was randomized. And then another challenge was writing different test case, like thorough test case to make sure that we hit it all the edge cases. And it's really important because it helps me make sure that my code is robust to different scenarios. And overall, I think it was a really great experience doing this project, and I really learned how crucial it is for for developing and testing to go hand in hand. It's just not just about making the code work, it's also about proving that it's work in every different scenario, and also learned the importance of understanding the project code base, expectations, and the standards before start contributing and working on it. So that's it, and thank you for watching.